we are still going to be working with solving two-step equations. Just our two steps are going to be a little bit different than the two steps that we talked about yesterday. So, in this first example that we see, based upon what we learned in chapters 1 and 2, the focus is going to be to combine like terms. Now, since our like terms are on the same side of the equal sign, we can just simply combine them together. So 3x plus 2x is going to make 5x. So 5x is now equal to 15. And now, based upon what we've learned with solving one-step equations, we can divide both sides by 5, and x is equal to 3. Okay, and if we check that, 3 times 3 plus 2 times 3, plugging the x value of 3 in for both x's on the left side of the equal sign, is equal to 15. Let's see. Well, 3 times 3 is 9, 2 times 3 is 6, 9 plus 6 equals 15. So check, it works. Alright, in example 2, one of the things that I'm doing here is I'm just putting the x on the right side of the equal sign as opposed to on the left side like we've seen in a lot of our other examples. We're still doing the exact same thing. Since the 4 doesn't have an x and the 16 doesn't have an x, those are going to be our like terms, and so the opposite of adding 16, or the inverse operation, is going to be to subtract 16. So we're going to subtract 16 from both sides of the equal sign. That cancels. 4 minus 16, if you need to, use your calculator. You should end up with negative 12 is equal to negative 2x. Now I have a one-step equation. Since the negative 2 is sitting next to the x, it is multiplying, so the inverse operation is going to be to divide both sides by negative 2. Negative 12 divided by negative 2 gives me a 6. The negative 2's cancel on the right side, and that equals x. So x is now equal to 6. If I check that, 4 is equal to negative 2 times 6 plus 16. Well, 4 is now equal to negative 12 plus 16, which is the same thing as 16 minus 12, which is equal to 4. So check. X equal to 6 works. Alright, if we look at example 3, what's special in this case, and we've done a bunch of these with our one-step equations, is the fact that we have a negative x here. Okay? And since the x is not the first term, it's the second term, we have a plain old 7. Since this is 7 is sitting all by itself, it's a positive 7, so therefore the inverse operation is going to be to subtract 7. The whole idea of using the inverse operations is we want the 7's to cancel. Well, 7 minus 7 will cancel out. Well, if I subtract the left side of the equal sign with 7, I have to subtract the right side with 7. That leaves me with a negative x. Big mistake that a lot of people make is they drop the negative sign from the x, but you have to bring that down. So notice I'm bringing down that negative x. Okay? Now, negative 3 and negative 7 is going to combine to be a negative 10. Negative 3 minus 7. Again, use your calculator if you need to. I have a negative 1 here. Okay, an invisible negative 1. We've seen this a bunch of times now. Okay, so I'm going to divide both sides by negative 1. That cancels out the negative 1's on the left, leaving just plain old positive 1. And then negative 10 divided by negative 1 is a positive 10. So x is equal to 10. If we check that, 7 minus 10 equals negative 3. Well, 10 minus 7 is positive 3, so 7 minus 10, if we flip it around, is negative 3. Okay, check, it works. X must equal 10. In the fourth and last example, the only difference here is now we're dealing with the fraction. We've talked about fractions a little bit already. Okay, so it's just reminders. Again, we want to combine like terms, so we are going to add the 2 first to isolate the x value. That leaves us with a 3/4 x equal to 12. 2's cancel, and 10 plus 2 is 12. To get rid of a fraction, we multiply both sides by the reciprocal. Okay, so I'm going to multiply it by 4/3. 12, I want to rewrite in the form of a fraction, so I'm just going to write that as 12 over 1. Over here, the fractions cancel, leaving just plain old x. And then on the right side, when you go to multiply fractions, the top numbers multiply and the bottom numbers multiply. So 12 times 4 gives us 48. 1 times 3 gives us 3. And then we can type that into our calculator, and x will equal 16. Okay, so our x value is equal to 16. Okay, we always want to try and simplify this, these fractions if we can. If we check this, 3/4 of 16 minus 2 equals 10. Well, 3/4 of 16 is 12, minus 2 does equal 10. So check, it works. Alright, so we're still working with solving two-step equations. We're just looking at some different types of two-step equations, some involving fractions, some involving combining like terms, some involving a negative x. Alright, so again, we're just taking this step at a time. Be ready for your warm-up tomorrow, and bring any questions that you might have.